I'll also record section. So no more proprietary stuff from my clients right now. Okay, we've discussed this. I'll not go into this. We also discussed this. I'll talk about this because this is particularly relevant for conversational search. I'm also going to talk about re-rankers. We've discussed synthetic data and query rewriting. We've discussed this BM25 for title and paragraph. I think this was also there in the diagram which I pulled from the internet. So it's a fairly common pattern actually. Uh, how do you combine these things? Reciprocal rank fusion is a very common way to do this. Uh, I wanted to call out two different types of re-rankers. This is what this slide is for to remind me of that. Um, there are two different types of re-rankers. One is very popular, like cross encoders. What cross encoders do is they take a question and a bunch of documents and then return a reordered list, right? So they will swap the order, change that in some way. That is what basically they do. Within that, there are pairwise, which will do one question, one answer at a time, and then they will give you a score and you can sort them again yourself. Or you can take the entire list and they sort it and return it. These are called pairwise and listwise, respectively. And the second is when a re-ranker is adding some information which was not there in the original list, which is not coming from question but something else altogether. It can be from the question, but it can be completely different signal as well. So re-rankers like Colbert, that is basically what they do. They basically use a different interaction type. It's a different model. So that means you can use it for re-ranking as well. In a lot of systems, including conversational search, your re-ranking will not only factor in what the content is about, but also who the user is, how recency the interactions are on that, and frequency of those interactions. So, as an example, let's say you want to rank results from the three or four people I talk to most on Slack, then in other ways. Similarly, you want to rank the results if you have some sort of understanding of the organizational structure because of titles and things like that, titles, teams, and so on, or the Slack channels they are in. You can implicitly use that as an organizational structure. So, okay, these are the areas which a person is looking at. Uh, then you can use that to also change your re-ranking function. This is reciprocal rank fusion. It's a very common way to combine lexical indexes like BM25 with other indexes. So, for instance, you can think of these as title, paragraph, and embedding, and then you basically combine them using the RRF formula. RRF is particularly fun, or basically rank fusion based methods are particularly fun to me because you can combine as many rankers as you want, even if their scores are not in the same range, right? So for instance, BM25 can give you scores like anywhere from, let's say, like, I don't know, -2 to 3,000, depending on what your numbers look like. Whilst embedding similarity will usually be between -1 to 1 or 0 to 1. How do you combine them? That becomes a problem. What rank fusion based methods, and particularly as an example, reciprocal rank fusion does, it only uses the rank information. So A will now get a score of 1 by 4 because it's first. Here A will get a lower rank. Here A will get something in between, and then you can combine them. The scoring is determined basically by this formula. And we usually use K as a constant. The 60 comes from the original paper. But I have systems in which this has been tweaked per category and things like that. And that's perfectly fine. It's an empirical number you can move around by running a grid search. Um, I still have Sayyed's question on my mind. So let's go to that. Yes. Um, yes, this is what I wanted to consider. In this diagram, consider that this is not, let's say, a recommendation system, but a conversational search system. That's what mentally I would request you to map to. And now, the moment you have that, you can treat each interaction where somebody is saying something as simultaneously a new action as well as a feedback for the previous action. This is exactly how recommendation systems model it, right? So, for instance, if you went on Netflix and you watched the video which is in the top panel, that is one interaction. Even if you have not clicked anywhere, that is an implicit interaction. The duration for that is always measured and part of the feedback system. Similarly, if you watched a video by clicking play, if you converted after watching that, that is second, and the feedback for the previous system. So conversational search systems in that sense are very similar. That if the conversational search system is giving you pain in life, the odds are that you're missing one of these two key areas, whether you are not using the interaction part of it to fine tune things, or you're not using the feed, like pass it to the previous step kind of relationship. So I think I gave some ideas on how you can use channel information. Oh, another thing. I know one very clever team. What they've done is they've used the equivalent of, I think, the Microsoft Teams. They're called groups. I'm not really sure, sorry, from top of my mind, but they're equivalent of Slack channels to make an implicit clustering based graph where they would use not just whether you are in the same channel as information, but how actively you participated in a channel and how quickly do you mark it as read at that time as your sign of interest in that channel. And I think all of these three information is something which you can get from Slack. And it's very powerful now to think about it, right? I will go to the channels which are most important to me and read those first quite often. So yeah, that is fairly clever in my mind, and then they were able to build a graph which self-updated based on this, and then they use it for querying. The nodes were the people, and the edges were weighted by metadata, a linear function of number of channels, how quickly they market, how active they are in those channels, and how frequently they participate in it. So they figured out a way to combine frequency, recency, activity, which is basically duration, a number of channels into one edge function, which is what they use to score the edge. So the edge in a graph was basically scored by one float value. You could also think of it as a multi-edge graph, but they didn't complicate it. Uh, After all of this, I really wonder if they needed a graph for this, if the function was ultimately linear. But they believe that the function will get more complicated than linear, and then they will move away from graphs or double down on it. Yeah, that's the context. What's your thought on Kohli Pali? It's good on evaluation strategy. You can use the sentence to answer. I did not really fully understand your question, Sangeeta. Here is how I interpreted it. Um, is Kohli Pali lossless compared to text? I wouldn't say it's lossless. I think anything which is using pixel information instead of a character stream is going to. Let's see, do I have that here? No, I don't have that. Uh, okay, let's leave that on. I don't have one diagram on Kolipali, but anyway. So is that lossless? No, I don't think it is lossless. I know they claim it to be lossless. All that they're saying is that we do not ignore a piece of information. That's not what you mean by lossless. Uh, would I use Kolipali if my indexing system allowed to use it? Definitely, because even if I have near perfect OCR, it is helpful to have some information around the layout of the document itself. That is a signal which our classical text-based systems do not really capture well, and neither do pure image-based systems. So Kolipali strikes that middle ground of capturing pixel level information while still, and that pixel level information in turn does map to some sort of page structure, and I think that is useful. I expect that Kolipali and that idea of that way of thinking will definitely get easier and better from today. So in case, let's say you're working in an enterprise setting where tech is relatively slower to move, you can literally just wait 6 months. And I know we like to be at the state of the art, but if you have tried running Kolipali locally or you have used anything which is a played index, that's the underlying index, what it's called, it is a giant pain to maintain and update because it's a file system based index. There is so outside of Vespa, if you're doing it, it's painful. So do not do that. In general, I am a fan of multimodality in any search or RAG pipeline, especially for documents, because humans do infer a lot from all sorts of visual information. Now, be that be structure itself, let's say of the page structure, or let's say in e-commerce, we know that changing images changes the conversion ratio. We know that for Airbnb, very famously, they got professional photographers to get photos of properties, and that changes things. Swiggy and Zomato know this. They hire professional food photographers. That is why you will see the same vada pav for almost all restaurants in Delhi and Bangalore because they all use the same vada pav photographer. And that photographer is lazy sometimes. So yeah, that's the. But in general, I'm in favor of combining signals or information which is not captured. So multimodality, if it adds information which is not captured in text, let's I would love that. I always like more signals basically. Yeah, cool. Um, did I answer more most of these questions? Did I miss something? Let me just scroll back up. Ryan, Shri, metadata, embeddings, Anita's question. Okay. Wanted we won't it be Pali Pali is not a more lossy embedding. I would say it's a different signal. Um, So I think lossy here, let's say if we were to measure it by mean average precision or mean average errors, I wouldn't say it would be more lossy. I think it would be a completely different signal. So if you were to remember all your ensemble theory from Kaggle or anywhere else, you should think search modern search functions like that. You ensemble and structure sequence a lot of signals. So from that lens, it will be a very different signal. I wouldn't say it will be more lossy because it's not like it ignores the text completely. It does pay attention to structure, but it does not ignore the text completely. That is why it works for text at all. So yeah, that's the reason why we are even discussing it today. Yeah, since we are discussing vector indexes, this was my shorthand diagram for what you should look at in search power versus yeah. You can see that Elastic and Vespa are quite. Oh, sorry, no, this is I believe this is Vespa. This is VV8 and Quadrant. They're way more scalable. Vespa and Elastic are less scalable sometimes, especially without horizontal. So their vertical scaling is lower, but their indexing is much more powerful. Here, I'm not talking about Postgres directly with PG Vector, which is HLSW, but the ingestion times were slower, the update times were slower, but they're good in other ways, especially if you're doing a lot of filtering. Let's say if you're building a Slack kind of search, you can look at Postgres to begin with and then migrate to a more powerful system later. If you are already, let's say, exceptionally good at Postgres. If you have no particular love for Postgres, do not distract yourself because Postgres is a great RDBMS, but it's not a great search system. And the difference between search and RDB is exceptionally important. So all the things which we're discussing, like how will you, one of the questions including which the Pancho had was an indexing metadata. In Postgres, if you had to index metadata as strings, you would be indexing like 15 columns. Your Postgres will start breaking at some point. It will start crying. So your vertical scaling is going to get limited. That's the bottleneck. The other thing is most vector DBs will allow you to split the vector index between RAM and disk, as well as allow some cool things like quantization, which saves a lot of memory and disk as well. I was going to talk about how do you select embedding models, but since we did not really ask that question, it's fine. Uh, One thing which we really did not cover, because we were a lot more search focused, was RAG itself. So I just want to spend 2-3 minutes on RAG. Um, I would like to think, uh, and my controversial opinion is this: I think there are only 2 to 4 patterns of RAG which really matter in terms of prompts. Uh, and these are the only 4. I would say there are probably 2 or 3 more, but these are the 4 which are the most frequently used and best tested. So that's the and this is from DSPY. You should not really bother going beyond that. But there are more questions. Okay. I want to do a POC on audio-based retriever. We've documented store and transcription and middle became worker for Korean insurance assistance. Are you interested in audio-based retrievers in future? Yes, I yes, definitely. So I think how we extended Colbert from text only to images and document images in particular, I think audio extension would make a lot of sense, especially because we don't use any of the MFCC features or anything like that right now. So that would be incredibly powerful if you can do similar kind of extension like Kolipali did or Kolijema did for audio. So that would be a phenomenal retriever or a ranker, depending on your size of the model. So yeah. And if you can do that for Korean English, which I happen to know, I spent a year at Samsung, I would be exceptionally impressed. For anything which works with Korean or Singlish, Korean English or Singlish is impressive in spoken dialects. How is Quadrant more scalable than Elastic? HNSW. Um, so there are a lot of ways in which these HNSW indexing implementations differ. So I wouldn't say more scalable. I meant by vertical scaling, like so for instance, for the same RAM. For example, Elastic puts some limits on one of the reasons is they have different configurations, which makes a lot of difference. The other is Elastic is built with BM25 first. Quadrant does not even have BM25 for that matter. For the rest of the audience, Dipanshu, I believe, knows that since he has called out Splade. Uh, so one is the settings and implementation of HSW. The second is how frequently do you read and how frequently is your disk paging happening, which changes your disk IO times, which in turn impacts your throughput. That is very different in Quadrant and Elastic from the best of my memory. At least that was the case in April, and I believe, given how fundamental this is to both their designs, that will not change. So the simplest way of thinking about it is this. Elastic was built with BM25 first, Lucene and Solar indexes first. Those are the indexes which are stored in brought from disk to RAM first, and then HSW is brought to disk to RAM and used in some shape or form. The first class citizen is always going to be the Lucene index or the Solar index. Anybody who's implementing KNN right now for dense vectors is probably doing it wrong, because I mean VVA does have a dynamic index which goes from flat to HNSW. Uh, but not a fan of those approaches. I understand why they did it because it helps with some parts of their multi-tenancy. It is a clever solution to a problem in their ecosystem, so I like it for that. Uh, but yes, it boils down to how your disk IO is happening, how that paging is organized, the disk to RAM IO for the index as well as the metadata. Uh, and Quadrant, because it works better with the OS instead of trying to replicate or fight the OS, does some of those things better. Yeah. Did I answer that question? Links to online articles or decks, several technical terms that is used in this meeting. For search in particular, I would really think that spending time on queryunderstanding.com is great. Uh, for other vocabulary. I believe there is a blog from so one thing is for a lot of vocabulary, you should just use perplexity. Do not go through that pain. Make your life simple. That is definitely what I would recommend. What else can I find? Yeah. So let me put this on screen. Where did this go? Yeah. So you can look at this awesome LLM vocabulary. This will have a lot of LLM specific things, how you can build LLM, how you can think about those, all of that stuff. In general, it's a good search shorthand. So you can search for anything awesome, something. This is a GitHub convention of talking about technical things. This will give you a lot of things. So as an example, I maintain awesome NLP, which we talk about a lot of NLP ways of things, the NLP tasks. So if you were to go to any of these things, you will see that this is organized by tasks within that. So we talk about taggers and parsers and all the classical NLP things. Uh, Similarly, you can see vector database. Yeah, here it is. There might be two or three versions of this. That doesn't matter. So you can see all of these, and when you go back down to these, you will see a lot of uh, what topics are they talking about. That will be here. Um, Speaking of vector databases, let me show this as well. Yeah. So this is superlink.com/vectordb comparison. Just search for this vectordb comparison. This will give you the latest on almost all systems which support vectordb in some shape or form. Everything from Elastic to Melisearch to MongoDB, which support vectordb, from their licensing to what search features do they have? Uh, to whether they have dedicated APIs for any of these things. So, as an example, a lot of them do not have dedicated RAG APIs, but I don't think it really matters. I'm not sure why Quadrant has a dedicated RAG API, but it does. Um, these are all the deployment setups. These parts like quantization helps with saving your RAM, so directly drives to cost. Um, Index types, we discussed HNSW, which is what powers most lot of modern vector indexes. Uh, you should, if you want to look at enterprise adoption of something, you should definitely look at Docker pulls because that is usually a function of how frequently something is being put in a automated Kubernetes cluster. Yes, Ryan has shared Hamel's force. That is excellent. It's a little how do I put it? It's quite long and large, and it's dedicated. It's very focused on fine tuning. So that's the challenge. But otherwise, yes, it's a great primer. I wouldn't say it's a 101. Yeah, that's the only reason I didn't recommend that first. Um, but yeah, Pramod, if you have a specific area which you have an interest in, like you want to do a 101 in, we can talk about that. Before we part, so that my team does not yell at me, I have to talk about this. I'm doing a search for rack course, which is going to be a much deeper dive into everything which we have discussed today. We are also building a dedicated system, basically a Kaggle for rack with our own data sets. So one of the data sets is going to be about protein data set so that it's not contaminated by like the LLMs are not already trained on it. Uh, so that's the kind of things which we're going to look at. All your apps will be exceptionally fast all through the day when you're building it. But the moment you want to do a demo in front of 20 people, it will break or slow down, depending on how unlucky you are. Murphy's Law. But anyway, so yeah, that's the link at the bottom. I'll actually let me put that link on Zoom chat as well. Uh, yeah, and this should I'll also put the promo code here. So that should give you a 20% discount. Yes, that's the idea. If there are more questions, I'm happy to take them. Yeah, that's but yeah, this was the time which we had. So I'm happy to take more questions. I have time. I don't mind that. But yeah, cool. I don't While we are waiting for, in case there are any more questions, I wanted to quickly show what we are building. This is about 1 month away from actually going live. So this is what it looks like this. But we're going to have a bunch of challenges and we're going to have rack specific metrics for that. Faithfulness, which is basically one minus hallucination rate, answer correctness, entity recall, which covers search. We'll have dedicated API tokens for each person so that you can do curl and upload these things and then evaluate those for you. So yeah, we're basically making Kaggle for RAG. This is our API doc, which is also quasi-public. So yes, because this is not behind a TikTok token wall. Yeah, cool. Uh, yeah, I think that's it. Any thoughts on DSPY versus building your own prompt flow? Uh, if you are getting started, I would like if you're starting a fresh project, I would suggest using DSPY because building chain of thought and getting that scratch pad right and then trying to figure out signatures and then all of those small things right is it's just not worth the pain. The most and then there is fun parts about DSPY. So as an example, let's say you write an instruction for prompting. Do you want to hand tune it? It sounds like something like fine-tuning your random forest by hand kind of thing in 2015. Not a fan of doing anything by hand if the machine is cheap enough. Uh, so DSPY, especially with the Micro V2 optimizer, does that really well. I don't know of any other system which does that as well. I know Text Gradient has an optimizer as well, but it's nowhere as good. So yes. Any other 101 type resources I can look up for search? There's an excellent book called AI Powered Search by uh, on Manning. I wouldn't say it's 101, it's everything from 100 to 102, but that's a great book. Chris Manning's higher book is OSS and great. Chris Manning is the father of information retrieval. His work predates. He's the creator of a lot of the ideas which we use today, including token indexes, keyword indexes, all of the ideas of how we should index them, how are they structured, like from tries to everything. They are, all of those come from the IR book. Uh, predates basically did a lot of the work in parallel to DBs. So you will see a lot of the influence which IR book has had on DBs as well. But it's a phenomenal book. It's available for free on usually on Stanford's website. Just look for Introduction to IR. It's a book which goes back to 2009, I believe. HTML editions are quite often available. Whenever I say indexing, what does it mean? Right? It's just some sort of probabilistic key hash which we are using. All of those construction, compression, tolerance, hierarchical clustering, all of those concerns are something which the book addresses. It's a great intro to IR. That's the. Let me actually see if I can find the URL. Yes, I do. Yes, this is a great 101 book. It's taught to undergrads at Stanford, and I believe most of us are smarter than that. So yes, smarter than undergrads with respect to search. Yes. Uh, cool, cool, folks. Yeah, I'll stop here. Thanks a lot for your time, folks. Please feel free to ping me anytime and see you on the internet around. And if you do want to sign up for the course, say hello. If you have questions about the course, say hello. If you know folks who would benefit from this, please send them my way. I will be happy to answer questions about the course as well. Yeah, that's it. Bye. Thank you so much.